Hi there, how are you? I just wanted to provide a video answer for this particular problem because that's a problem of conical pendulum. And it's quite a bit of details and graphics that had to be shown in order to explain it well for you. So that's why I did this video. Okay. So what you have here is a ball of unknown mass m. So he didn't give you the mass for a reason. We'll go on it in a second why. And that is attached to a string of the length is L is given to you 1 meter, and it forms an angle of 20 degrees with the vertical. The string forms an angle of 20 degrees with the vertical, and is asked to find the tangential velocity v, which is supposed to be in meter per second. So you need to find the tangential velocity v. If you look at this at a circle, so let me draw a circle here. Draw this circle like that, and you have a this ball is right here, and it turns one revolution, complete revolution. We do not know the time, we're not given, but the ball will have a radius of rotation, which is going to be little r here. Okay, that radius of rotation, which is little r. Okay, and you're asked to find what's the tangential velocity of this, which means the ball will have a velocity like so, heading in that direction. And if it was, this is called v tangential. And if the ball was here, okay, we still have the same radius r, and the velocity will be like this. It's a vector, and it's called tangential velocity because the vector is tangent to the circle at this point. Okay, that's why it's called tangential velocity. Now, from normal circular motion, we know that the velocity is equal to omega r. Okay. Now r can be determined easy because from this here, a right angle triangle, this is 90 degrees, and this will be your r. So it's simply, if you take the sine of 20 degrees, you will get the opposite here, which is r, the opposite, divided by the hypotenuse, which is L. So r will be simply sine 20 times L. Okay, that's your radius. But the problem here is, what is omega? So you need omega, which is the angular velocity, which you do not know what it is. It's not given. All you're given is that the length is L, and it forms an angle of 20 degrees with the vertical, which we solved for r, and the mass. And the mass is not even given to you. So, and you will wonder how you will probably solve this problem. Well, the best thing to do is isolate the forces, take a free body diagram, isolate the force M, the ball M, from its surroundings. So basically, I'm going to draw it here. This is your ball M. So this ball, when you isolate it from its surrounding, it has a vertical, its weight. What's acting on this ball, basically, we're saying. What's acting on this ball is its weight here, which is W of the weight of the ball, which is M times G. Okay, M times gravitational acceleration. And if you cut the string here, you will have a tensile force, tension in the string of T. We call that T. Okay? So that T has two components, has a horizontal component and a vertical component, like so. So for simplicity, let's call this T sub y, which is a vertical component, and T sub x, which is a horizontal component. Now looking at this angle and this angle here are alternating angles. Therefore, this angle is also 20 degrees. Okay. This angle here and this angle here are alternating angles, so the 20 degrees. Therefore, this angle here is a 20 degrees angle. Okay. And so we apply the principle of what? Newton's second law. Okay, so Newton's second law says sum of the forces in general equal to the mass times acceleration. Okay, and the acceleration is a vector, and the forces also is a vector because they're in the, it could be either in the positive or negative direction, could be whatever. So the forces are vector and the acceleration is a vector. The only thing that's not a vector is m. Okay, so if we resolve this more, if we take some of the forces in the x direction and we define that the positive is in this direction equal to 0, what are the forces that are acting on this in the positive direction? Well, it's at tx only, right? So it's at tx equals to mass times acceleration. Now, what acceleration are we talking about? Up here, if the force is acting this way, therefore it's a centripetal force that's pulling toward the center of the circle. So this is origin O of the circle. And so that centripetal force, centripetal acceleration can be expressed as A centripetal is equal to V squared over R. And so what's V squared? Which V? V is that tangential acceleration that we were looking for. Okay, so we could put this like that. Tx is equal to m V squared over R. Very simple like that. Okay, so now I need to find what Tx would be equal to. Okay, so now Tx, based on the force diagram that I have above, is equal to T sine 20, right? T sine, because the angle is here, so Tx equal to T sine 20. Okay. Now there's something here also missing. Is there something else in the Tx direction that we need to know about? Well, no, that's it. So it is T sine 20 equal to m V squared over R. Okay, simple as that. Now we need to find T. Okay, we do not know T, it's not given to us, but we need to find T in terms of something in order to solve this. Okay, so let's look at the forces, sum of the forces in the y direction equal to 0. And we assume the positive sign, the positive forces are up. So what do we have? We have mg, which is a negative force coming down, so minus mg, and this t is projected in the positive direction, so it will be that Ty, so mg plus Ty, equal to also the mass times the acceleration in the y direction. Okay. Now, what are things here you have to basically identify? The acceleration in the negative in the y direction is zero because the ball is suspended. Okay, it doesn't move down, it doesn't move up. Therefore, the acceleration here is zero, which makes this equation minus mg plus ty equal to zero. Okay, and the ty equal to mg. But what is ty? Well, ty is nothing but t cosine the angle. So t cosine theta is equal to mg. Therefore, t alone is mg over cosine theta. So this is what we need. We're going to take this and we're going to plug it right here. Yeah, we're going to plug it right here. You're going to get mg over cosine theta, that's t, times sine theta, so g cosine theta, times sine theta is equal to m v squared over r. Do you see what's going on here? We just plugged in the value of t that we got from the sum of the forces in the y direction into here to simplify this. So here you got, you notice immediately that this m and this m cancel out. So that's why he did not give you the mass, because he knew at the end that the mass is going to cancel out. That's why. Okay. So you end up here with g sine theta over cosine theta. So let me continue this here. You get g sine theta over cosine theta equal to v squared over r. V squared over r. What is sine theta over cosine theta? Well, it's tan theta. Okay, so we can write this down here as g tan theta, tangent theta, equal to v squared over r. Now, all I'm going to do is solve for v squared. Okay, so v squared is going to be r g tangent theta. And v, which is a tangential velocity, that's what we're looking for, is square root of rg tan theta. Okay, that's it. So we know what r is. We said r is sine theta L, or L sine theta. So v tangential is going to be square root of L sine theta what? G tan theta. So Vt, V tangential, I'm going to write it down here because I'm running out of room, is equal to square root of, and we'll enter all these values, square root of L, we know it's 1 meter times sine theta sine 20 times g is the gravitational acceleration is 9.81 meter per second squared times tan theta. Well, tan 20, if you go, it's calculate tan 20. What the hell has happened here? So if you calculate tan 20, let me just write it down here, tan 20. Okay. Now what's important here is to look to see you got meter times meter, you got meter square, and divided by second square. Therefore, when you square root this, you're gonna, and these are unitless, tan theta and sine 30, tan 20 and sine 20, they're unitless. Therefore, you're gonna get an answer in meter per second. That's first check. Now I can do calculations. So 1 times sine 20 times 9.81 times tan 20. I got 1.2211 meters squared per second square, and I'll take the square root of that. I got 1.1 meter per second. That is your tangential velocity. Okay, let me make a quick checks here for calculations. So I got 1 sine 20, that's my R, times 9.81 times tangent 20, 1.22, take a square root of that, 1.105, I'm just gonna call it 1.1 meter per second. And that's how you get around not knowing what omega is in order for you to solve this problem. Okay, I hope you like this video, and if you would like extra help with other things, just contact me on Wyzant. Take care. Bye.